Computer simulation of FFLGN, gallium-doped graphene. It is very well known that graphene and FFLGN are considered as expectationally promising materials, which are in many applications of more interest than graphene in itself. One more interesting material, FFLGN, GO, graphene oxide, that is graphene functionalized with oxygen-containing chemical groups. This material is promising as an intermediate product for producing graphene in large scales. Additionally, it can be used for producing new materials for electronics, material science. In the last few years, there has been an increase of attention to functionalization of graphene with radiation techniques. For example, forming radiation defects and doping them by atoms of different elements. These conceptions represents a new way of producing graphene-based 2D nanostructures, functionalized with elements like gallium, S, and B, nitrogen, bore, S. Such materials are promising for prospective application in non-electronics, super sensitive sensors, electrical power sources, flexible electronic and power devices. But it is not yet well understood about stable atomic configurations of graphene functions with individual atoms of different elements, in which way they can be produced in graphene nanostructures, and how to obtain characteristics needed. It is in some cases a rather difficult problem for experimental researcher and proper interpretation of data. In this situation, computational simulation and study of functionless graphene-based nanostructures became a very effective research tool for better understanding the physical and chemical properties of such materials and predicting their characteristics. In section, we demonstrate results of the computer simulations of some possible stable structures of gallium-doped graphene and fuel-layer graphene, and the first principal study of their energetic and structural characteristics. It is known that gallium in its common state is a metal with a very low melting point, 30 Celsius degrees, but when gallium atoms are arranged separately in two-dimensional graphene structures, all basic properties can change very essentially. For first sections, we present results of computer simulation and density functions theory, DFT calculations within a DMOL-free software package of possible stable configuration of FFLGN. Fuel-layer graphene functionalized by gallium atoms. All calculations were performed using local density approximations and very effective method of energy optimization with using periodic boundary conditions with convergence tolerance on energy 0.0001 electrovolt.